Hello friends, welcome to my YouTube channel Make Maharashtra. I hope you understood last session, that is selection procedure of V-belt from manufacturing catalog. So we have seen all the chart. I'll just revise this. We have seen this belt section, selection, then what will be the value we need to select for inside length, then pitch diameters of the pulley, power rating factor we can select from this graph, and this will be the only one equation to calculate number of belt. Selection of the chart, FA, inside length. Clear? So we'll solve the numerical. So please listen carefully, understood, and then solve from your side. I'll read the numerical. It is required to design a V-belt drive to connect 7.5 kilowatt power at 1440 rpm. Power 7.5 rpm, smaller rpm, that is smaller pulley rpm, 1440 rpm. Induction motor to a fan running at approximately 480 rpm, that is bigger pulley rpm, for a service of 24 hours per day. So according to, we need to select FA, correction factor. Space available for a center distance of 1 meter, 1000 mm. Okay, now one by one we make the solution. See, first of all, as I told you, we need to select the belt section, which belt section is suitable. So power is 7.5 kilowatt, rpm 1440. So for that we need to select C. This is the chart. What it indicate? Power is 20, I forgot, sorry, 7.5 kilowatt. 7.5 kilowatt. So it is situated somewhere here, correct? 7.5 kilowatt with 1440 rpm. You can see 1440 rpm somewhere here. So here we'll meet approximately. So section is B. So B belt section we need to select, B belt section. Okay. Now for selection of B belt section, it means that this value we have selected, and width is 17, thickness 11, and pulley diameter 200 mm. So same I will have to follow. Here pulley diameter for smaller pulley 200 mm diameter I have taken from the chart. So therefore capital D is equal to, so I know N by N is equal to D by D. So therefore diameter of bigger pulley is, here we should not do 2 times, because that is in case of the flat belt drive. Here we will have to do the ratio according to speed ratio. So it gives you 600 diameter, correct? 600 mm diameter. This is the first step. Understood, friends? Okay, we'll go for the length. L is equal to, this is V belt drive, open belt drive always. So L is equal to 2C plus 5 into D plus D divided by 2 plus D minus D bracket squared by 4C. So I'll put the value C we know 1000, capital D we know, small d we know, and through which we have calculated the length, and that length is 3296 mm. This will be the length of V belt drive. This is the total length. Now inside length means, as I told you, this will be the inside length, Li. So Li need to calculate, and that will be definitely less than this, correct? So see, Li is equal to L minus 43. Li is equal to L minus 43. L we have calculated 3296 minus, now 43 comes from this. See, B section 43. So we'll get the value Li is equal to L minus 43, that is 3296.64 minus 43, that is 3253 mm. This will be the inside length. Clear? Next, from this table we'll get the value 3253 inside length, correct? So 3253 we'll have to check in the inside length value. So inside length table, 32, I forgot value, 3253. So I select 3253. See this 3253, 3251 is there. This is the nearer value, correct? And our belt section is B. So I'll select FL, corrected length is 1.08. So understood? For this 1.01 for B section, inside length. So inside length I have used FL 1.08, correct? Now axial factor, that is load correction factor 1.3. How we can select? See, as they have mentioned, is 7.5 kilowatt induction motor. So I'll go to the application factor. Up to 7.5 kilowatt induction motor is there. So 7.5 kilowatt, and which is working for how many hours? 24 hours. So 24, it means you just check 24 hours and 7.5, it will gives you 1.3 FA. So I will put the value FA here. See, FA 1.30. Okay, FL and FA selection. Now arc of contact factor alpha is equal to pi minus 2 into alpha. Barabar? Theta is equal to, this is theta. Theta is equal to 180 minus 2 alpha. So alpha is nothing but this. So by putting this value, diameter we know will get the 156.93. That will be the value of theta. This is value of theta, correct? 156.93. Now there is a graph to select the value of arc of contact factor. Earlier it was the chart in flat belt drive. Now here is the graph. You can see this graph. So graph is theta versus FD, arc of contact factor. Now our value is 156. 156 somewhere here. I'll project this, and this will be your value. It will around 0.9596, correct? Therefore my FD value is 0.94. You can take it, no problem. 0.94 from the this chart, 156, and this will be the 0.94. Okay, understood? 156 and we have to project, that is 94, that is 0.94. So we'll get FL, FA, FD. So we know the equation, number of belt is equal to transmitted power, that is 7.5 we know, into FA 1.30, kilowatt rating 5.23. So 5.23, how to calculate? See, our diameter is 200. So belt rating, one chart we forgot to check. So this, our section is B, belt section, and the small diameter is 200. Am I correct? 200. And for 200 the power rating is 5.23. So 5.23 I have added here, 5.23 power rating. Understood? Then FD, dynamic load, which we have calculated, arc of contact 0.94, and FL is 1.08, which we have selected from the chart. So by this way, number of belts are using for V belt drive 2, 1.84, that is 2. Clear? So I hope you understood this process. I have thoroughly explained this process, how we have calculated, how we have designed the V belt drive. So please check it, understand, solve from your side, do practice. If any query, you can ask me. Thank you.